Hi everybody, nice to meet you here again. So in this video I would like to talk about pressure instruments, how it works and what common malfunctions there could be. And I would like to cover the situations when for some cases a pitot tube or static port blocked, for example in case of the icing or in case of the having some obstacles in them. So for this let's start, and for this let's remember which instruments are related to the pressure measurement. So in this six-pack we can see three instruments that are related to the air pressure. The first one is the airspeed indicator, and the second one altimeter, and the third one is the vertical speed indicator. So three others are related, not related to the pressure measurement. They are gyro instruments. So let's have a look to the components of those three instruments. Everything is easy. So we have pitot tube. This is the rim air pressure sensor, and we have static port. This is the static air pressure. This static port is placed like in the position of the airplane to catch only the static pressure of the ambient pressure, let's say. So it won't pick the change in the pressure which related to the speed of the airplane. I mean, we also have alternate static source. We need it exactly for the case if we for any reason have a static port blocked. And we can see here all three instruments that we mentioned above. So airspeed indicator, a vertical speed indicator, and altimeter. This airspeed indicator connected directly to both of the airlines. I mean the ram pressure airline and static pressure airlines. So this instrument measures the difference between two pressures in those two airlines. And a vertical speed indicator connected just to static airline, and it measures the change of the static pressure in time. And altimeter, it just measures the absolute pressure and indicates you current pressure and current time. So how those ports looks like. So this static port is just some kind of port placed on the side of the airplane. It can be just on the one side of the airplane, or you can have two static ports on the both sides of the airplane. Depends on the model of the aircraft. Also, as we said, there are some alternate static air pressure port placed in the cabin of the airplane. And this is the ram air pressure, the pitot tube. This pitot tube placed in the direction of the movement of the airplane. So it looks to the front of the airplane with this teeny small hole in the front of it. So the more speed we have, the more air pressure we will have in the inside of this tube. This tube have a kind of heater in the case to prevent the icing in case of the sub-zero temperature. And let's have a look just for a second again to the same picture, to the same scheme. So again, the airspeed indicator is, as we said, connected to the ram pressure and static pressure ports, and measures the difference between those pressures. So when we stay on the airfield without movement, the difference will be zero. We will have no difference, and airspeed indicator will display us just zero airspeed. Again, just vertical speed indicator and altimeter connected only to static pressure airline. So that means that altimeter just measures the current pressure, ambient pressure. So you can set this instrument to some kind of altitude of the airport when you stay on the ground, and when you fly, when you climb, I mean. So in that case, you will have different pressure than was on the ground. So this instrument will indicate you the current pressure or current altitude. Vertical speed indicator, we will discuss a little bit later in details, measures just difference of the or change of the pressure in time. So let's have a look how everything works. Let's start with the problems we have in case of the pilot tube or ram air pressure sensor blocked for any reason. So this is the schematic scheme of the airspeed indicator of this instrument. So this instrument, case of this instrument is pressurized and connected to the static airline, and it has a kind of box, pressurized box, which could expand or collapse if we change the pressure inside of this box, and this box is connected to the ram air pressure line. That means if we increase the pressure in the pilot tube, this box will expand, and this mechanical link will move the needle of this instrument, and this instrument will show you the current airspeed, the difference between the pressure in the side of this box and inside of the case of the instrument. So what happened if we block the pilot tube? Obviously this instrument will not respond on changing the airspeed, but it will stop measure difference between those two, just difference between those two areas. It will also respond on changing the altitude or physically changing the pressure inside of this box or in the static airline. So how it will look? When we decrease speed, again you'll have frozen indicator. But when you descend, so as we all know that the density of the air increases with the lower altitude. That means that when we descend, we have more pressure, more ambient pressure, I mean in the case of the of this instrument, and we have the same pressure inside of this box. That means that this airspeed indicator will read less airspeed, and in opposite, when we climb, the ambient pressure will decrease because the density of the air will decrease. That means that the difference in the box and in the case of the instrument will decrease, and this will increase, and this indicator will show you more airspeed, more indicated airspeed. So let's see what happens if we have static airline blocked. Again, we see it on example of the airspeed indicator, because this indicator is connected both of the airlines, both ports. So we'll have kind of a similar situation, but except that airspeed indicator will show us change in the airspeed normally. It just won't show you accurately the current airspeed, because this line is okay in our case, and if we change the airspeed, if we gain speed, or if we lose speed, so this box will work normally, instrument will work normally, and it will show you normally the change in the airspeed. But because the static airline blocked, this instrument, airspeed indicator, will catch also the change in the altitude or in the pressure, in the ambient pressure of the air around us. So how it will work? Again, if we increase or decrease airspeed, this instrument will show you properly increase and decrease indicated airspeed. But when we start to descend, we will have more dense air with descending and more pressure around the airplane, more ambient pressure. That means that this difference in pressure will affect on the pressure inside of this box, expandable box, and this change of the pressure will add it to the change of the airspeed. So this indicator will think that we are changing airspeed, we are increasing airspeed. The same when we climb, the ambient pressure will decrease, and from the point of view of this instrument we will have less airspeed, so it will show us that we decrease actually airspeed. And so the situation with altimeter and VSI is much easier. So what happened if we block static port and what happened with altimeter? So this instrument works as follows. The static port is connected to the box of the instrument, the case of the instrument. So when we change the pressure inside of this case, this expandable box, metal box, will expand or collapse, and through a mechanical link it will move the needle on the front of the indicator. So we can just set the position of this needle by the knob and set 0, for example, or the elevation of the aerodrome when we just staying on it. And so when the pressure, outside pressure, will be changed, for example when we climb for some level or some altitude, this instrument will measure the current pressure and shows us the current altitude related to the place where, or to the level where we set this instrument before. So what happened if we block the static port? Actually this instrument will just freeze. I mean it won't show us difference in the change of the pressure. That's it. And so what happens if we have the same static port blocked? What happened to VSI, I mean the vertical speed indicator? So this instrument indicates us the difference between in changing the pressure on time. So as we see, this instrument is connected to the static port with two lines. First line is connected directly to the expandable box, and the second line connected to the case of this instrument through special calibrated tube or hole, which allows us to flow the air slowly. So when we change the pressure in static line, this expandable box will will expand or shrink rapidly at the same time with the change of the pressure in line, and the needle will show us that we are climbing or descending. But in a couple of seconds, if we stop changing the pressure in the tube, the pressure between case of the instrument and the box will equalize. So that means when we just level it off, this VSI will show us 0. Again, if we have static port blocked, we won't see any changes, so we won't see any indications on this instrument. And let's imagine what happened if we just have both pressure ports, static port and pipette port, blocked. What happened then? I think the answer to this question is obvious, so you can answer it for yourself. So thank you very much for attention. Hope to see you next time. Good luck!